Okie doke. So today's presentation runs for about 20 minutes. Well, it's 20 minutes slot, so I should have a little bit of time for quick Q&A at the end. So I'll be fairly rapid, but there's three things I really want to cover in today's presentation. Firstly, I'll give a bit of an overview of digital engineering and how that is part of an evolution in our construction industry towards smart infrastructure. And I'll talk about digital transformation and the new capabilities that I personally believe are essential for us to move forward as an industry. So just very high level about Dios Digital. It's a relatively new consultancy, as Timothy mentioned. Dios has been around, well, it kicked off in March. We provide digital strategies for a smarter, more connected world. Prior to that, I spent 14 years at Transport for New South Wales, and 7 of which I was leading the Digital Engineering Framework Program. You can find out more details about Dios on the website. So just also some of the recent projects I've been working on, I've been helping out the Victorian Digital Twin Program, been doing a bit of work in Canberra, looking at the rollout of digital engineering for Canberra Light Rail Stage 2, doing a bit of work over in New Zealand with the Let's Get Momentum Moving program. And most recently, I've just kicked off producing the digital engineering standard for the rail sector. So that should be coming out next year, AS 7739. So it's been a busy time, but it's great to see industries and government is keen to move forward. So we're here today to talk about technology, and it would be remiss not to mention Industry 4.0. And this really changes everything. It's really changing all sectors and all parts of life. I've just put a variety of different icons up there about things like drones, blockchain, 3D printing, virtual reality, everything to do with Internet of Things, remote sensors, big data. It goes on, and it is such a game changer for all sectors. And when we hear about change, you often hear the line that change is the new constant. But I'd like to just reframe that. So acceleration is a new constant. In this book, Evolving Digital Leadership, there's one line that really stood out for me, and that was that today's pace of change is the slowest we will ever see. Things are only going to accelerate as more technology becomes ubiquitous. And it's really an exciting time to just see just the rapid changes. And even just in the last 20 years, you can see how things have changed, and the next 20 are just going to move even faster. That rate of change, however, or the rate of acceleration, is not evenly spread. And you can see that technology providers have been producing all sorts of new tech over the last, say, 20 years or so. And that has really given rise to a lot of personal sort of consumer tech. So everything that you have on your phone and every other device that you may have on you. Businesses have been, we've seen adaptation from consumer tech into the business world. And a great example is running a conference online right now. Public policy, however, has been languishing, and it's difficult for public policy to keep up with this rate of change. So one of the themes I'll be talking today is where I see government can make rapid improvements to try and bridge this gap. So we're also here to talk about the construction sector, and this image has been doing the rounds for many years. Autodesk published this about 5 years ago. It talks about the construction side of the future. And I'll start, it shows a range of different technologies, but if we just look at, say, the bottom left, we've got this worker talking to his manager on the iPad. He's got wearable tech, so it might be something a bit like a DAQRI helmet, the augmented reality perhaps. You've got the side office where everyone's working in the cloud, and I guess that's just modern life now, where I guess everyone's home office is a bit like a side office. We have construction where it's all prefab. You've got site sensors and drones and equipment, which is all automated. So a whole range of new tech that have slowly made their way into the construction industry. But I'm most interested down the bottom right with the manager, looking at the different outcomes. So high quality, safety, on time, on budget. That's really the point of new technology. It's to try to get to these outcomes. And for us to evolve as a sector, I believe that there's a path that we're loosely sort of following. BIM was really the catalyst for change. And when the UK government back about 10 years ago announced that they were looking at a mandate for what they called level 2 BIM at the time, that triggered all sorts of change in the way that we looked at information management, design workflows, and how BIM could be integrated with many other data sets. In the work that I was leading at Transport, we saw that BIM was really one part of a broader landscape of digital deliverables that we had to try and integrate together. And that's where we landed on the term digital engineering. But digital engineering will provide the foundation of structured data. And then that allows us to then look forward to like the next evolutions, such as the digital twin, and beyond that into smart infrastructure. So let's talk about where things are going, and then we'll talk about how we're going to get there. The digital twin is such a buzzword. It's kicked off all sorts of excitement, a lot of interest, and there's a whole heap of new players now entering the construction industry, all sort of pitching visions for what the digital twin could be. So given today's presentation is all about tech, I'll give you my vision of how I see the digital twin working. And it's really about building physical and digital assets. So let's talk about two swim lanes. The top lane, we have the digital twin. And what I've tried to represent here is the BIM model, plus also all the other databases, all the other structured data that we want to associate together into this ecosystem of digital engineering. So when we finish a project, we'll have an as-built model plus all of our data in structured databases that can all be linked in a common data environment. In the bottom, we have the physical assets. So starting with site investigation, moving to enabling works, so clearing your site, to then eventually you built a brand new building or a bridge or a railway. But the new change is the introduction of IoT remote sensors. So when we hand over these assets and they move into operate and maintain, we now have this coupling between the digital twin that will live in the cloud and the physical assets, which now have instrumentation. So remote sensors that can measure all sorts of things, such as in transport space, patronage, congestion, asset performance, timetable performance, but it could also be any sort of environmental measurement. So any form of pollution, air, dust, noise, vibration, can all be tracked and fed back up to report back onto your digital twin. So with this digital twin, we can undertake visualization, simulation, machine learning, and data analytics. So in response, we have more informed data-driven decisions. And I believe this is what the vision or where our industry is now heading. And if you scale up to just a single project or a single site, to every new project starts building more and more of these digital twins that are all done consistently. So then we can have a network model for linear infrastructure, so rail, roads, utilities, and we have a network of physical infrastructure which all has remote monitoring. So then we're going to be a lot more advanced in how we can operate and maintain our infrastructure as a whole. So I'm going to call that smart infrastructure. Another basic way of just representing that is, this coupling between the digital twin and physical assets. Well, we have our physical assets now with remote sensors and our real-time data link. And we have our digital twin that enables machine learning and data analytics, so we can have more informed data-driven decisions. Together, the digital twin and the physical assets with IoT sensors form smart infrastructure. So this enables improved operations and maintenance. Our infrastructure can give us all sorts of early warnings well before failure. So we can have early detections of anomalies and anything that may affect performance of the assets, so services aren't going to be disrupted. So digital engineering, as I mentioned, this is a stepping stone towards digital twin and smart infrastructure. So what is digital engineering? I've been using this diagram for many years, and what I'm trying to represent with this has always been that the starting point was BIM. And I know there are many definitions of BIM out there. If you get 5 experts in the room and ask them what BIM is, you're going to get 6 or 7 definitions at least. But for the sake of simplicity, I'm just going to call BIM smart 3D models. So it's the evolution from design in 2-dimensional drawings to 3D models for visualization. The next evolution being object-based 3D models, where the objects have attributes, which means you can do smart things. So clash detection, visualization, stakeholder engagement. But the real benefit by having common attributes is that you can link that BIM model with other data sets. So with time for 4D and cost with 5D. And you can extract an asset register, so 6D. But what's of most interest is all these other data sets as well. So let's go beyond the 4D, 5D, 6D, and just talk about an ecosystem of data sets that can all be linked. So GIS, which is really important for linear infrastructure when you're not just looking at single projects, but you're integrating into networks. Also requirements management, risk management, document management, and many other data sets we look after in our projects. We want to be able to create databases for each one of these that can be linked by common data. And that's really the aim of digital engineering. So we want to move from business as usual where, look, we have been producing BIM models in industry for many years, but the objects have often had their own unique coding. The same way CAD drawings and survey and GIS and the schedule, they've all been breaking down and describing the same projects in a slightly differently. And the coding that they've been using has all been different too. So we've ended up with an ecosystem of file-based siloed data sets. Where we want to get to is that by having common attributes across all these data sets, we can have an ecosystem of databases. And this is really that foundation of structured data. So then we can start looking at digital twins and smart infrastructure. So just looking at that on another way, over the life cycle in our projects, we have life cycle stages and we have gates. And typically on projects, they'll just produce the files to enable that stage of the project to get approval to pass through the gate. And then it's over to someone else. It's like the next part of the chain. It's the next, sort of consultants or builder who will then create new files just to be able to get through the next gate. But the future, where we want to get to is that we have linked databases or a common data environment that enables buildup of information as we go through each lifecycle stage. So when we get to the end, it's a lot easier to transfer from CapEx to OpEx, but also we have a complete line of sight backwards because everything has been managed in structured databases. So an analogy I give is a bit like a factory line or production line of cars. And if you think about production line, at every stage along this production line, we're always building, starting with raw materials to building the chassis and the car doors. And it's always building as we go. And we want to do something similar with the data that we produce over the life cycle of our projects. So this isn't a novel concept. In the UK, they talk about the golden thread and they try to represent it in this sort of way. And I believe this is really what they're trying to achieve. There's also other organizations as well. So Infrastructure Pathways, which is more focused on sustainability, but equally, they're also looking at this digital asset lifecycle. And so we need to have people that can design, not just produce the information in our projects, but to design that production line. So let's now talk about digital capabilities, and I'll try and wind this up pretty quick because it'd be great to have a little bit of Q&A. But I see that there are 4 new digital engineering capabilities that are essential to enable us to move forward as an industry. And the first one is the digital engineer. And I'll call anyone who's producing BIM models, so 3D, 4D, 5D, GIS, parametric design, somebody that may be flying drones around doing photogrammetry models or laser scanning. These are the people that have the new skills using new software, hardware, processes, but they're essentially creating new deliverables in a digital way. So there's a whole ecosystem of software out there in the BIM space, and I'd say that this sits in the world of the digital engineer. Now, the next level up, a role that we introduced when I was at Transport was the digital engineering manager. The digital engineering manager's role is not so much the production or to be a technologist of the deliverables, but to manage them on the client side. So a client side project manager of digital engineering. And these people are essential because this is a new set of skills. We don't expect everybody to know straight away. We need project champions that can do that. Now, the next 2 levels is where it starts getting a bit tricky. I believe these 2 levels are a bit harder to find. The digital engineering developer is not somebody that is working on projects, but they're the ones that are designing that production line. They're the ones that do 2 things. First of all, they create a digital engineering framework within an organization. So that involves standards, processes, data schemas. But secondly, once they've created that future state, that digital ecosystem, they then have to integrate different parts of the business one by one into this new ecosystem that we call the digital engineering framework. And I would say these people are rare because there are very few government or client agencies at the moment that have been engaging people with this sort of skill. But I believe this is essential to take industry forward. And the last one up the top is the advisor. And this is a role that I've fallen into over many years of working in the space. And the advisor is all about planning, executive engagement, creating the influence. But the deliverables are more than just vision, policy, objectives, and so forth. It's about producing a business case and a funding strategy to be able to have the budget and resources available to then bring in developers to create that production line within each government agency. So you can sort of see that there's a mix of skills. Each has their focus, but I think for us to succeed as an industry, we're going to need a bit of all four. So just quickly over a timeline, if I talk about the kind of work that I've been doing, I see that there are 4 stages of getting this working. The advisor provides advisory at the beginning, so the vision and high-level recommendations and roadmap. The strategy is the business case. How are we going to get the resources and the budget to be able to make that change? In delivery, that's when you deliver the digital engineering framework to create that future state. And finally, implementation of projects. So I see this as a bit of a path that, it seems to be working fairly universally with a variety of different organizations. And I think this is going to be the key to unlocking digital transformation in our industry. Now, I will try and wind it up there, but I'll just leave you with one final thought. I appreciate there has a fair amount of content and the world of digital can seem complex, but my one final thought is just to keep calm and go digital. There's an exciting world, ahead of us, and with the right strategy in place, we can do great things.